Welcome to Simple Sciencing. Today I'm doing the 2018 GCE O-Level Combined Physics Paper 1, which consists of 20 MCQ questions. In this video, I'll be doing the full work solutions for these 20 questions. So if you have any questions or don't know how to do a particular question, please look through this video and understand the question. If you have any questions, do comment in the comment section below. Without further ado, let's begin. Question 1 says that a voltage of 2 mV is applied across a resistor causing a current of 4 microampere. Which rho gives the voltage in volts and current in ampere? So this question is a test on prefixes. You should know that 2 mV can be written this way and 4 microampere can be written this way. The prefix for milli is times 10 to the power of negative 3, and the prefix for micro is times 10 to the power of negative 6. Since the answers in the table are given in decimals, you should express your prefixes in the base prefix form. So 2 times 10 to the power of negative 3 will give you 0.002, whereas 4 times 10 to the power of negative 6 will give you 0.000004. By comparing your answers with the table, you'll realize that option C is correct. Next question. Two forces act as right angles at the point O as shown. So this is point O. What is the resultant of the forces? Firstly, you need to understand the meaning of resultant. So the resultant force actually means the overall resultant single force due to the effects of all forces at the same point. So now let's look at this diagram. There is a vertical force acting from O to R and a horizontal force from O to P. Both forces act at point O. So the resultant for these two forces will be in this direction, because there is a upward force and a rightward force. So the resultant force will point in the northeast direction. So we have determined the direction to be OQ. Next, how do we find the magnitude of this force? We can use the mathematical form of Pythagoras theorem to determine the magnitude. So OQ can be determined to be the square root of OR square plus OP square. This will give you 9 square plus 12 square, and the answer is 15. Therefore the answer is A. Question 3. A car is moving forward. Two forces act on the car as shown. So there is a resistance force R and a forward force F. When force F equals to force R, which statement is correct? So in this diagram, you are given that F equals to R. So what does it mean when the forward force equals to the resistance force? Yes, that's right. This will mean that the resultant force equals to 0, because the forward force cancels off the resistance force. Recall the formula of resultant force. Fr equals to ma. Since you are given that Fr equals to 0, it will mean that the product of mass and acceleration will be equals to 0. When product of mass and acceleration equals to 0, one of the products must be 0. So mass cannot be 0 because the mass belongs to the car, and the car cannot be 0 kilograms, which means that the acceleration is 0. So let's look at the options. Option A states that the car is moving with non-uniform acceleration. We will just say that there is no acceleration since A equals to 0. So option A is wrong. Option B states that the car is moving with uniform acceleration. Same as option A, there is no acceleration. So option B is also wrong. Option C, the car is moving with uniform velocity. What is uniform velocity? Uniform velocity means that the car is moving at constant speed. So when a car is at constant speed, the resultant force is 0 because there is no acceleration or deceleration. The car is moving at a constant speed, correct? And since the car is moving at constant speed with no resultant force, the acceleration will also be 0. So it fulfills the two conditions. Option C is correct. Now let's look at option D. The car is stopping. When the car is not moving, resultant force is also equals to 0, right? The car is not moving, and obviously acceleration will also be 0. However, do take note that in this diagram there is a forward force F, which means that the car is moving. So option D cannot be the correct answer, which leaves us with option C. Now let's move on to the next question. Question 4 states that a box of mass 50 kilograms is pushed across a floor with a force of 340 newtons. Total frictional force acting on the box is 320 newtons. What is the acceleration of the box? So this is a question that requires you to plug in the formula and find the answer directly from the formula. So recall a formula that connects the mass, the two forces, and acceleration. That's right, F equals to ma. Okay, this F is actually the resultant force. So how do you find the resultant force? You can use the subtraction of 340 minus 320. Why is this so? Because 340 is the pushing force and 320 is the frictional force. So the total resultant force will be the difference of these two forces. Sub in the other values and to find A. So rearrange this formula to get this, and A is given to be 0.4 meter per second square. The answer is A. If you are unsure of how to do this question, you may always draw a free body diagram of the box. Okay, this is the box. It has a mass of 50 kilograms and there is a pushing force of 340 newtons. There is a resistance force also pointing in the opposite direction, 320 newtons. Okay, so we want to find the acceleration. Okay, so the resultant force will be pointing in the rightwards direction. Subtract 320 from 340 to get the answer of the resultant force. Question 5. A gravitational field is a region in which a body with mass experiences a force. Which statement about this force is correct? Okay, so this question is a test on gravity. What is gravity? Gravity is a form of attraction. Yes, it is a form of attraction. So you and me are being pulled to the surface of the earth. However, it cannot be repulsive. If not, we'll be floating around. So A is wrong, because gravity cannot be repulsive. B, it depends on the charge on the body. It does not depend on the charge on the body. Gravity does not depend on the charge of the body, and it does not depend on the volume of the body. For B and C, we can use the formula W equals to mg to view this. G represents the gravitational field strength, which is given here. So the factors affecting G will be the weight and the mass. The charge and volume does not affect the gravitational field strength. And D, it keeps the planet in orbit around the sun. This option is correct because we have stated that gravity is a form of attraction. So the planets pull each other towards themselves and they will orbit around each other. So let's take a look at this diagram. This is the sun, and the sun pulls, there's a gravitational force in the sun which pulls the other planets towards it. These rings that you can see here, these rings you can see, they are actually the orbits of the planets. Okay, so the sun and the earth, for example, the sun pulls the earth towards it, and the earth pulls the sun towards it also. because of its own gravitational forces. Another example is the Earth and the Moon. The Moon, okay? The Moon also pulls the Earth towards it, and the Earth pulls the Moon towards it. So the Moon will orbit around the Earth. Question 6. The weight of a spacecraft on Earth is 1250 Newton and Mercury is 475 Newton. The gravitational field strength on Earth is 10 Newton per kg. What is the GFS on Mercury? So this concept tests you on the difference of weight to find gravitational field strength. Okay, so there's a lot of information, so you should write down properly. Firstly, the object on Earth has a weight of 1250 Newton. So we have the GFS of Mercury. So we have the GFS on Earth, which is 10 Newton per kg. We can find the mass using the formula W equals to mg. So by rearranging this formula, we can find m equals to W over g, and W is given to be 1250, g is 10. Calculate this, you get 125 kilograms. This is the mass of the object. The mass of the object is given to be 125 kilograms. Okay? Remember that the mass is same no matter or regardless which planet you are in, because the mass is the amount of matter in a body. So the mass will not change, whereas the weight of an object will change. Okay? Now let's look at the information for Mercury. The weight of the object on Mercury is given to be 475 newtons. So transpose this information to the Mercury. Because the mass will not change, you can find the gravitational field strength to be W over m, weight over the mass. Okay, so the weight of the object on Mercury is 475 Newton. Divide by the mass of 125, you'll get an answer of 3.8 Newton per kg. Okay, so the answer is D. Question 7. Each tire of a 4-wheeled toy car exerts a pressure on the ground of 3.5 Newton per cm square. The area of each tire in contact with the ground is 10 cm square. So what is the weight of the toy car? Now this question tests you on the pressure, okay, and area. So recall any formula that connects area and pressure. Okay, that's right. Pressure equals to force over area. Okay, you are given the pressure and given the area. This force is actually the weight. Okay, so we want to find the force. So we can rearrange this formula to be F equals to P times A. Okay, substitute the pressure to be 3.5 Newton per cm square multiplied by the area of 10 cm square. Okay, take note that this is not the answer because we only calculated for one tire, the area of each tire. Each tire 3.5 Newton per cm square, pressure for each tire. So we have to account for this 4-wheeled toy car. So this whole expression must be multiplied by 4. Okay, and the answer you get here is 140 newtons. Okay, therefore the answer is D. Question 8. Which device converts kinetic energy to electrical energy? Okay, kinetic energy is a form of motion and electrical energy is a form of electricity. So firstly, a hairdryer. A hairdryer actually converts electrical energy from the wall socket to kinetic energy of the blades in the hairdryer. A jet engine converts the chemical potential energy of jet fuel to kinetic energy of the turbine inside the engine. A wind turbine converts kinetic energy from the wind to electrical energy of the generator inside the turbine. And the electric motor is the opposite of a wind turbine because it converts electrical energy from the power source to kinetic energy of the motor. Compare this back to the question, kinetic energy to electrical energy. You realize our answer is C. Question 9. A person of weight 600 Newton walks uphill. He moves 10 meters vertically each minute. What is the useful power generated by the person? So this person has a weight of 600 Newton. And the rate of movement is given to be 10 meters vertically each minute. So I'll write as 10 meters per minute. Okay. We can find the work done of this person. Okay. Work done is given to be the force times the distance. This distance is the distance at which the force is act in the same direction or opposite of the direction of the force. Okay, in this case, in the opposite direction. So for the force of 600 Newton, because it's the weight, he moves up 10 meters per minute. So multiply by 10. This is work done per minute. Okay, because we are given the rate and not the distance. Okay, so this is given to be 6,000 joules per minute. So what is the power generated by the person? Okay, recall that power equals to work done over time. So the work done per minute is given to be 6,000. Okay, however, we need to find the time. Since this is in per minutes, we can actually calculate this very easily. But take note, the time must be given in seconds. So 1 minute is actually 60 seconds. Calculate this and you'll get 100 watts. Power is in watts. Okay, so the answer is B. Question 10. The rate of energy transfer from a body by radiation is affected by the number of factors. What does not affect the rate of transfer? So this question tests you on radiation. Okay, firstly, a color of the surface. The color of surface will affect the rate of energy transfer. Okay, so given a white surface and a black surface, the black surface will transfer energy faster than the white surface. So color of surface does affect the rate of energy transfer. A is wrong. B, surface area. The surface area, a wider surface area, will allow more energy to be transferred. So surface area does affect the rate of energy transferred. C, the surface temperature. A medium of higher temperature will allow a greater rate of energy transfer. So surface temperature is also not the answer. The answer is actually D, the surrounding air pressure. Why is this so? Let's take a look at atmosphere and vacuum. Okay, in the atmosphere where you and me are standing right now, there's an air pressure of about 1 bar. One atmospheric pressure is 1 bar, and 1 bar is given to be 1.013 pascals. Okay, however, the pressure in vacuum is roughly or nearly 0. Okay, because there is nothing in vacuum. The definition of a vacuum means that there is nothing, not even air, in the medium. So obviously, atmosphere has a higher pressure than vacuum. Okay, however, we are being tested on radiation. Recall that radiation can travel through outer space. It can travel through the atmospheric pressure on Earth. So, is radiation affected by the atmosphere or vacuum? The answer is no. It can still travel through vacuum. So, regardless of the surrounding air pressure, radiation is still able to travel through these different mediums of different pressures. Okay? So the answer is D, the surrounding air pressure. Question 11. The displacement distance and displacement time graphs are shown for a water wave in a ripple tank. What is the speed of the water wave? You are given the displacement distance graph, and from here you can actually find the wavelength. Wavelength lambda. Okay? And the displacement time graph allows you to find the period of the graph, which is denoted by t. So now let's look at the displacement distance graph. We can draft out the wavelength from here to here. Okay, this is one wavelength because of 2 points of the graph in the same phase. Okay, so this reading gives us 2 centimeters. The wavelength is 2 cm. Okay, from 0 to 2. Okay, for the period, same thing, from phase to phase, the period is about 0.04 seconds. So the question asks you what is the speed of the water wave. To find speed of the water wave, sub in the formula. V equals to F lambda. What is F? F is a frequency. And remember, frequency is given to be 1 over period. So sub in the values. Frequency is 1 over period. So 1 over 0.04 multiplied by the wavelength of 2 cm. And calculate this, your answer will be 50 centimeter per second. Okay, answer is D. Question 12. The diagram shows a ray of light incident normally on the side PQ of the glass prism. Critical angle of the ray of light traveling from glass into air is 42 degrees. What will happen to this ray? So this question wants you to trace out the path of light in this glass prism. Okay. Now, the only information given to you is actually this critical angle, which is 42 degrees. The question actually is testing you on the total internal reflection. Okay, so we need to trace this path of light from this PQ into the glass block. Okay, we need to trace the path of light. So the ray of light enters from PQ into the air. Is there any reflection or refraction here? The answer is no, because the ray of light is incident normally, which is 90 degrees on the surface PQ. So it will enter the glass block straight. Okay. Now you can always draw a normal to help you visualize better. Okay. Since this is 90 degrees, this is also 90 degrees. This can be calculated to be 45 degrees because angle sum of triangle. Okay, since this is 45 degrees, this angle will also be 45 degrees because the normal is always tangent to QR. They are always perpendicular to each other. So, since the incident angle, which is this 45 degrees, is greater than 42 degrees, total internal reflection will occur. Okay, what does this mean? It will mean that the light ray does not travel out of the surface QR. It will reflect into the glass block again. So this angle will also be 45 degrees because of total internal reflection. The angle of incidence will always be the same as the angle of reflection. Okay, so I'll just draw the path of light to be like that first. Okay, calculate the angles. This angle is also 45 degrees. Okay, because 90 degrees, remember. And lastly, this angle will also be 45 degrees. Same thing, angle sum of triangle. And to help you, you can always draw a normal here. So this angle, which is the new incident angle, will also be 45 degrees. Okay, because of the 90 degrees from the normal and the surface PR. Okay, so what will happen again to the light ray? Will it bounce back? The answer is yes, because 45 degrees is still greater than 42 degrees. Okay, it will bounce back. Okay, so here is about 45 degrees. Okay, when it bounces back out of the surface PQ, so this is the ray of light, the path of light traveled. Okay, the key concept here is that when the incident angle is greater than the critical angle, TIR occurs. Okay, this is the key concept. So what will happen to this ray? If by tracing the path of light, you realize that the answer is B. It will travel through the prism, reflecting from QR and RP before re-entering the air at PQ. Question 13. An object is placed in front of a thin converging lens at a distance equal to twice the focal length of the lens. Which description of the image formed by the lens is correct? Okay, so firstly, to help you visualize, I'm going to draw this diagram out. However, by answering this question, you are supposed to memorize the 5 cases of light being converged into the thin converging lens. So, to help you understand, I will draw out the light ray diagram with the thin converging lens. Okay, here. This is the optical center. Okay, C. Now, I'll draw the focal length to be F on both sides. Same length and twice the focal length to be 2F. Same distance. Okay. So the object is placed at a distance equal to twice the focal length, which means that the object is placed here, somewhere here. Okay. Okay, I'll use an arrow head to denote the object. Okay. So the object is placed here. So they ask you which description of the image formed by the lens is correct. Okay. So by drawing the light ray diagram, okay, I'm going to draw the light ray diagram. Okay, you'll pass by the focal length here, and lastly you can pass by this part. Okay, something like that. Okay, and you realize that it is pointing, sorry, it's not accurate, but it's actually pointing downwards, and it should meet at this point. Okay, please refer to the diagram. Okay, so after drawing the diagram, you will realize that the object is of same size. Okay, it is real because it is on this side of the thin converging lens, and it is inverted. So the answer is A. Question 14. The diagram shows the direction of electric field lines around an isolated charged object Q. A charged object R is placed in a position as shown. Okay, so what are the signs of the charge? So look at object Q. The electric field lines are pointing outwards. Okay, so what does this mean? Q is positively charged. Okay, and when R is placed near Q, there's a force of R pulling towards Q. So since Q is positive, it will mean that R is negative, because both will attract each other. Okay, so by cross-checking the answer, you realize that C is correct. Question 15. 3 2-ohm resistors can be connected together in series and parallel in different ways, which total resistance could not be obtained from the different combination of these resistors. So you have to draw out the resistor combinations for you to visualize. Okay, so firstly, if I connect the resistors in series, okay, you will actually get this. Okay, let each box be 2 ohms. Okay, when I connect the resistor this way, the total effective resistance will actually be 6 ohms, because 2 plus 2 plus 2 gives you 6. Okay, this is when I connect the resistors in series. Okay, let's connect the resistor in parallel. If I connect the resistors in parallel, which will look something like this. Okay, the total effective resistance will actually be smaller than one of the single resistor in each branch. So what does this mean? You can use the parallel resistance formula to calculate the effective resistance, and it should give you a value of 2/3 ohms. Okay, the other cases of the resistors that can be arranged is in the series parallel form. Okay, so what do I mean by series parallel? It means that in the circuit there is a form of there's a series circuit and a parallel circuit. So one example is this. Okay, I'll draw a parallel circuit first, and lastly a series resistor. So this is a form of series and parallel. Okay, so calculate this by calculating the parallel resistors first, then add up the series. This can be added up to be 3 ohms. Okay, and another case for series parallel is like this, whereby there's a series inside the parallel. Okay, calculate this and you'll get 4/3 ohms. So from all these combinations, you can actually find 2/3 ohms to be here. You can find a 3 ohm here and a 4/3 ohm here. So which one could not be obtained from the different combinations? The 4 ohm. There's no way and not possible for you to find 4 ohms of resistance, okay, from the combinations. Question 16. The graph shows a voltage current graph 3 equal lengths of the same material of the resistance wire X, Y, and Z. Okay, so you're given a voltage current graph. The resistance and cross-sectional area of wires change in going from X to Z. Which will describe these changes? So we want to know the trend from X to Z. X, Y, Z. We want to know the changes of the trends from X to Z. Okay. So what is the trend? We are given the voltage current graph, which means that the gradient of this graph is a resistance. Recall the Ohm's law. Okay, which states that V equals to IR. Okay. So since V is the y-axis and the I, which is the current, is the x-axis, this resistance is actually the gradient of the graphs. Okay, so as you can see in the graph, you realize that Z has a greater or steeper gradient than X, which means that the resistance will increase. Okay, bring this information down to compare with the cross-sectional area. Okay, you must know that when resistance increase, cross-sectional area will decrease. Why is this so? Because the cross-sectional area of a wire actually allows the flow of electrons from point A to B in a wire. Okay, so if you have a greater cross-sectional area, it will mean that more electrons will be able to flow through easily. So same, but vice versa, a smaller cross-sectional area will mean that electrons have had to squeeze their way through. Okay, so resistance is inversely proportional to cross-sectional area. If you don't remember this, you can always remember the resistance and the resistivity formula. R equals to rho L over A, whereby R is the resistance and A is the cross-sectional area. Can you see that they are inversely proportional? This relationship. Okay, so when resistance will increase, as shown here, cross-sectional area will decrease. The answer is C. Question 17. The diagram shows 3 identical bulbs connected to a cell. A copper wire is now connected between S and T. Okay, so which statement is correct? So I connect a wire from S to T. Okay, what will happen to this circuit? That's right, Q and R will not light up. Why? Because the wire connecting from S to T has a lower resistance. In other words, it has infinity resistance. Okay, because of its infinite resistance, current will flow through this copper wire instead of the Q and R. Current always flow through the path with the least resistance. Remember this. So we have a term for this and we call it short circuit. Okay, so short circuit will occur. Current will flow through from S to T through the copper wire and not the two bulbs Q and R. So which statement is correct? Okay, Q and R go out and P gets brighter. Is this true? Yes, A is the correct answer, because Q and R does not light up. But what will happen to P? When Q and R does not light up, the total resistance will actually decrease because Q and R no longer lights up. Current no longer flows through these two bulbs. And when the resistance decreases, the current will increase. Why? Recall the Ohm's law. V equals to IR. Okay. So you can rearrange this for you to visualize better. R equals to V over I. Okay. Remember that V, or the total EMF of this voltage source, will not change. Voltage source will forever be the same when the same cell is used. So V will be constant. This is a constant. Okay. So when R decreases, I will increase because they are inversely proportional. Okay. When there's more current flowing through P, it will get brighter. Okay. So more current brighter. So A is correct. B is wrong because the brightness of P will actually change. I've told you that there is more current flowing through this circuit, hence P will be brighter. Okay, it goes out. So for the other options, they are wrong, obviously. Question 18. The static diagram shows 3 different resistors and 3 meters with their readings. What is the value of resistor R? So we have to determine the potential difference across R and the current flowing through R before we can find the value of resistor R. Okay. So how do we do so? When we want to find the potential difference across R, we can connect a voltmeter across R. How do we get the value of this V, this voltmeter? We can use the subtraction. Okay. The total EMF is given to be 12 volts, and this resistor over here, which is in this path, is 6 volts. Okay. If you cannot visualize this circuit, always draw these arrows to guide you on the path of the current. Okay. Take note, at this point, current will split into 2 paths. Okay. So at this juncture, this node, current will come back again. Okay. So this is the path of the current I've drawn in the circuit. Okay. So this resistor, all the current in this circuit will actually flow through this part of the resistor. Okay. So what will happen is that we have to find the potential difference across resistor R. How do we do so? We have to use 12 volts subtract by 6 volts. Okay. So the potential difference across R, okay, will actually be 12 minus 6. We give you 6 volts. Okay. Some of you may be asking, so what is the potential difference across this resistor? Okay. Well, the answer is also 6 volts, because you have to remember that the potential difference across each branch in parallel is the same. Okay. So no matter how many branches you have in parallel, you have to subtract 12 by 6. No matter how many branches you have, they will also be 6 volts. Okay. So we have the voltage settled. Now we have to find the current of resistor R. How do we do so? We can use the subtraction of 1 from 3. Okay, so 3 minus 1 equals to 2 ampere. How do we get this answer? Because remember, I told you that all the current will split at this node and they will come back together at this node. So at this point, all the current, the total current in the circuit is given to be 3 amperes. And only 1 ampere of current comes by to this branch. So what will happen at this branch? That's right, just subtract 3 minus 1, you get 2 ampere over here. Okay, so you have the voltage and the current of resistor R. What do you do next? Use the Ohm's law. Okay, Ohm's law states that R equals to V over I. Sub in the values, 6 divided by 2, this will give you 3 ohms. So the answer is B. An electric heater takes a current of 4 ampere from a 250 volt supply when operating normally. What is the time taken for the heater to convert 400,000 joules of electrical energy? So from here, you have to find the power rating of the electric heater. So how do you find the power? There are actually 3 formulas for power. Remember, P equals to IV, P equals to I square R, P equals to V square over R. Which formula to use? These 3 formulas determined here is actually devised from the Ohm's law, V equals to IR. Okay. However, we are only given the current and the voltage. So we can only use the first one, P equals to IV. Ignore the other 2 formulas. So P equals to IV, I is given to be 4 multiplied by 250. So this is given to be a value of 1000 watts. Okay. So now the power is 1000 watts. What do you need to find? We have to find the time taken. You are given the energy. Okay. So recall that power is equals to the energy over time. We want to find the time. By rearranging this formula, time equals to energy over power. So the energy is 400,000. The power is 1000. Okay, calculate this, you will get 400 seconds. Okay, so the answer is A. Question 20. The diagram shows how a steel bar can be magnetized. Okay, So which statement describes how the steel bar can be demagnetized? So what is the meaning of demagnetization? It's actually to reduce the magnetism of this steel bar. So when you want to demagnetize a steel bar, take note that this is DC supply. This is for magnetization. Okay? So for magnetization, you use a DC supply. When you want to demagnetize, you always use an AC supply. Why? Because it damages the one-directional flow of the dipoles of the steel bar. Okay? So to demagnetize, always use AC supply. And then you need to gradually decrease the current in the circuit. Why? Because when you decrease the current in the circuit, you actually lower the possibility for the steel bar to be magnetized again. Okay? Right? It's quite logical for you to decrease the current in the circuit, right? So the answer is C. Okay? That's the end for this video. I hope you understand how to do these 20 questions. It's actually quite simple. If you have any questions, please comment down in the comment section below. Till the next video, see you.